NASA asteroids warning. DART mission is Earth's last line of defense. Well, it's a planetary defense system, and it's about time we had one. Unfortunately, this should be a worldwide endeavor to protect the Earth from incoming celestial rocks. NASA is readying to fire a spacecraft into an asteroid. It's going to test Earth's last line of defense in the case of a rogue space rock coming towards us at a trajectory to impact the Earth, that is, a collision course with our planet. Japan's Hayabusa 2 spacecraft made history April last year after firing a bomb at asteroid Ryugu in an attempt to collect a sample of the space rock, but a much more violent asteroid rendezvous is being prepared by NASA. The space agency is planning the DART mission, where a space probe will be blasted on the mission into an asteroid, testing the last line of planetary defense. We know that asteroids have all shapes and sizes, and they've been impacting Earth for billions of years. One of them, 66 million years ago, was believed to have caused the dinosaur extinction, besides other animals and plant life, not just the dinosaurs. That was the asteroid that fell into the Yucatan Peninsula of Mexico. But here, only once every few million years, an object large enough to threaten life on Earth arrives. Patrick Michael, director of research at France's Côte d'Azur Observatory, believes the double asteroid redirect test, or DART for short, double asteroid, we can learn a lot from the Hayabusa 2 mission as well. Now, he said that for us, this is an exciting first data point to compare with simulations, but we have a much larger impact to look forward to as part of the double spacecraft asteroid impact and deflection assessment AIDA mission. In late 2022, the U.S. double asteroid redirect test, or DART spacecraft, will crash into the smaller of the two twin asteroids, Didymos. It's an asteroid. It has a little moonlet. Well, the spacecraft will crash into the smaller of the two, which is the moonlet, circling around the bigger of the two asteroids, like an Earth and a moon type of thing. Now, as with the Hayabusa 2 SCI test, it will form a very distinct crater and expose subsurface material in an even lower gravity environment, but its main purpose is to actually divert the orbit of this little moonlet, the Didi Moon. It's 160 meters in diameter, and it's not only to collect the sample, but they have to make sure that they're able to take it off its trajectory. So it's like a live run type of thing, a small live run. Now, the DART spacecraft will have the mass of 550 kilometers. It will strike the Didi Moon asteroid at 13,400 miles an hour, and smashing into the asteroid 5 times smaller than the aircraft, which is more than 200 times larger and moving 3 times faster, they said should create sufficient impact energy to deflect this little moonlet, this part of the double asteroid, in the first such experiment for planetary defense. It's the first time they're going to do this. Now, the European Space Agency mission called Hydra would then visit little Didymos to study the diverted asteroid, measure its mass, perform high-resolution mapping of the impact crater that has been done by the DART NASA spacecraft. Dr. Patrick, who is also serving as Hydra's lead scientist, says the actual relation between the projectile size, the speed, crater size in low-gravity environment is still not well understood. Having both small carry-on impactor CSI, small carry-on impactor, and Hera data on crater sizes in 2 different impact speeds will offer crucial insights. He says these scaling laws are also crucial on a practical basis because they underpin how our calculations estimating the efficiency of asteroid deflection are made, taking account the properties of the asteroid material as well as the impact velocity that's involved. And he said this is why Hera is so important. Not only will we have DART's full-scale tests of asteroid deflection in space, but also Hera's detailed follow-up survey to discover Didymu's composition and structure. Hera will also record the precise shape of the DART crater right down to centimeter scale. So building on this Hayabusa 2 impact experiment, DART and Hera, between them, DART is NASA, Hera is from European Space Agency, they will go on to close the gap in asteroid deflection techniques, bringing us to a point where such a method might be used for real. In other words, okay, they've got to do something, because it's just a matter of time, right? We even have impact craters on the moon and Mars, not just Earth. So Didymoon, the little moonlet, will easily be the smallest asteroid ever explored, meaning the space rock will provide insights into the type of material and the environment of the gravity, the negligible gravity, more than a million times weaker than Earth's. I just hope this, once they explode this, they bomb this little moonlet, that these fragments don't go and hit the spaceship, because then what happens if that happens? There's no more spaceship, so you don't know, you can't get your results back. Anyway, this is what's going to be happening in 2 years from now, and I'm glad they're doing something about trying to mitigate what could be coming at us. This is on Express UK by Tom Fish. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.